here's what's left of section 1.6. So first off, we're going to deal with what's called systems of three equations and three variables. We use what's called the double elimination method. You pick a variable to eliminate twice so that you can reduce a system of three variables into a system of two. Then we solve the new system for a variable and use substitution to find the remaining variables. So I'm going to start this one off by noticing that it's pretty easy to eliminate x at least once. I'm going to have to do it twice because I need a system of two equations, okay? But if I just add those pieces together, I will have no x, I will have 4y, I will have 4 z's, and 3 and 13 sums to be 16. Now for my next magic trick, I'm going to multiply this line right here by a positive 2. And that's going to give me negative 2x plus 4y plus 2z equal to 6. And the reason I did that is because I realized if I added it to the first equation, I'd be in business. So if I add down, the x's are gone. There are 5 y's, there is a singular z, and 6 and negative 10 sum to be negative 4. So I'm just going to write that right underneath this equation, and then I'm going to use my God-given brain to think about what I want to do next. And my next little magic trick, by the way, what I just did is I went from a system of 3 to a system of 2. Now that I have a system of 2, I get to use the lesson that you guys learned Monday. Yeah, you guys did this lesson Monday. I'm going to multiply this one by a negative 4. If I do such a task, I'll have negative 20y minus 4z equal to 16. I'm going to rewrite this line right above it. 4y plus 4z is 16. Then I'm going to add down. Now 4 plus a negative 20 is negative 16y. The z's cancel out. 16 and 16 makes 32. Divide out the negative 16 and I have negative 2. So we're right here. We solve the new system for a variable and use substitution to find the remaining variables. So I have y. I can go back and I can just plug it in right here and I can get z. 4 times a negative 2 plus 4 z's is a 16. This is negative 8. Negative 8 plus 4 z's is a 16. I add 8 to both sides, I get 24. I divide by 4 and I get 6. I have x and y, I have y and z. I can use substitution and I can plug them in to an existing equation and I can get the last variable x. So 2x plus y, which is negative 2, minus z, which is 6, must be negative 10. Now these two sum to be negative 8. If I add 8 to both sides, I get negative 2 on the right-hand side, 2x on the left, so x is negative 1. Now, how do I respond with this answer? Well, the answer is what we call an ordered triple, which goes x, y, z. X was negative 1, y was negative 2, and z is 6. So let's go back and look, okay? So I pulled up Desmos earlier and graphed this system. When you talk about systems with three variables, we still call them linear systems, but they're actually equations of planes, flat surfaces. And they all intersected right there at that point. That's where they all three cross paths. They cross paths where x was negative 1, y was negative 2, and z was 6. Z gives you depth. It gives you the ability to do things 3D. As opposed to the xy axis, which is just two-dimensional thought. So z is going to give you some depth. And there you go, kids. Like, that's it. That's where they all cross paths. That's where they intersect. Now this guy had one unique answer. We classify as consistent independent. That is our classification. Moving forward, and I know kids are going to just moan and whine. If this wasn't on YouTube, I'd probably say something else, but they would moan and whine about these. In 1995, yeah, I was a kid then. I was born in 1980. In 1995, I remember doing 5 variable equations by hand. That's a double elimination method. You'd have to take a system of 5 variables, reduce it to 4, so that's elimination 1. Then you would reduce it to 3, so I did elimination again. Then I reduced down to 2, so I did elimination again. It's a lot of elimination method, and then you do the substitution property. But I mean, I remember doing it. So surely you guys can handle 3 variables, right? All right, next one. Let's see here. What do I want to go after? I want to go after y, just because I saw that, okay? So if I just add these two together, I'd have 3x plus twice z is 8. Now, since I attacked y once, I'm going to have to do it twice. And I feel like, of course, there's lots of ways to get around this one. I actually know the shortcut to this one. I'm going to multiply this top equation by negative 2. That'll give me negative 4x plus twice y minus 2z is negative 6. And then I'm going to add it to the bottom equation. Negative 4x plus twice y minus 2z. Aw. I guess I didn't get the shortcut on that one. Or maybe it doesn't happen yet. So negative 4x plus twice y minus 2z equals 0. And let's just add down. There are negative 8x. Oh, I see. I'm just really off today. Milbrath. I just need to double it. 4x minus twice y plus 2z is 6. Negative 4x plus 2y minus 2z is 0. So I multiplied the top one by 2 because if I had 4x and I added negative 4x, I get nothing. So I'm doing the first and third equations. Now what's cool is I have no x, I have no y, I have no z's, and equals 6. Now 0 plus 0 plus 0 has always been 0. This is a false statement. 0 is not equal to 6. This literally means no solutions, which by the way is classified as inconsistent. Now let's take a look at this. Now remember, these things with 3 variables are what we call planes. They're flat surfaces. What this means is all 3 do not intersect. It doesn't mean that 2 of them might intersect. It just means all 3 of them do not intersect. So let's take a look at what that looks like on good old Desmos. Clear off my existing stuff. There's one flat surface, there's another flat surface, and the next one's going to have to be parallel to either one of these for no intersections. And that's exactly what's happening. Those 2 flat surfaces there are parallel and never cross paths. Anywho, moving forward. Next thing is matrices. How can a matrix represent a system of linear equations? And this should say equals C. Its standard form is ax plus by equals the constant. So we're going to represent these using matrices. And you probably have no idea what a matrix is. It used to be a big deal back in the 80s and 90s. In math, a matrix is a rectangular array of data that is organized into rows and columns. First off, we're going to get these things in this standard form where the x's are first. So we're going to have 2x plus 3y is 1. The next one's going to be 4x minus twice y is 10. We're going to construct what's called an augmented matrix where the first column is x, the second column is y, and the third column is c. We denote the equality sign with a bar. That's just what we do. That's equal, okay? So the last one is the constants, which are 1 and 10. We keep only the coefficients, which are the numbers in front of the variable. Some of you guys have no idea what a coefficient is, and that's what we call an augmented matrix. Now the rest of the notes are really like super easy. Just write down matrices. Moving forward, a system of 3 variables. So a system of 3 variables would have an x column, a y column, a z column, and a constant column. And all we have to do is pick out the coefficients. There is 1 x, there are 2 y's, there are no z's, and the constant is 2. there is one x, there is a negative 1y, there are 3 z's, and the constant is 5. There are 2 x's, could have sworn I changed colors, there's 1 y, there's negative 4 z's, and the constant is 10. And that's a big deal. I mean, I've done this for years too, like the textbooks write on this. This is a huge common error. You cannot set up as an augmented matrix until both equations are written in standard form. And that's what you got to think about, good old STD form. Moving forward, almost done. These are the triads. Write the matrix for the system of equations or the system of equations for the matrix. So this guy only has x, y, and a constant, and it's only got 2 rows. It's got 3 columns, x, y, z, and it has 2 rows because there's 2 equations. 3 x's, negative 1 y, bar for equality, 4. Negative 2 x's, 7 on the y, 20. Now this is the other way around. Remember, this is taking the matrix and writing the equation. The equation for row 1 would be no x, it would have 2 y's, it would have 3 z's, and it would equal 4 because we have the nice little dashed line, the bar. This guy would have 8 x's, it would have a negative y, it would have a negative twice z, and it would equal 5. Last one would have 2 x's, it would have no y's, it would have 1 z, and it would equal 9. Easy peasy lemon squeezy. And hey, that's the notes for Thursday. I'm sure you just loved watching that video. I enjoyed making it for you.